All right, let's talk about a classic coding headache, the linked list. But more importantly, we're going to dive into this really elegant technique that can totally clean up your code, get rid of a whole class of bugs, and just make your life a whole lot easier. You know the feeling, right? If you've ever built a linked list from the ground up, you know the drill. You're constantly checking. Is the list empty? Am I adding to the head? Am I deleting from the tail? It gets messy, and it gets messy fast. And this is where things get really tricky, especially with doubly linked lists. Every single one of these edge cases, the empty list, the first node, the very last node, they all need their own special logic. And this kind of patchwork of conditions, it just leads to bloated code. And you know what bloated code leads to? More bugs. Now, don't get me wrong, doubly linked lists are awesome. Being able to go forwards and backwards is a huge advantage. But, yeah, there's a catch. Every time you insert a new node, you've got to correctly wire up 4 different pointers. You've got the new node's next and prev, and then you have to update the pointers of its new neighbors. That is a lot of room for error. So this gets you thinking, right? What if we could just get rid of all those special cases? What if inserting at the front or in the middle or at the very end all use the exact same logic? It sounds a little too good to be true, but it's totally possible. And the way we do it is with something called Sentinel nodes. The best way to think about them is as permanent guardians, or maybe like bookends for your list. They just stand there at the very beginning and the very end, and their whole job is to make everything that happens in between way, way simpler. So what exactly is a Sentinel node? Well, basically, it's a dummy node. It doesn't hold any of your actual data. Its entire reason for existing is structural. It's a fixed point, a landmark that your code can always count on being there. Okay, this is the real game changer. When you add these permanent head and tail sentinels, your list is never technically empty. It always has these 2 placeholders. This means the first real piece of data is always at head.next, and the last one is always at tail.prev. You've just completely eliminated the need to check for null pointers at the ends of your list, which, as you know, is a massive source of bugs. Okay, so the theory sounds great, but let's see what this actually looks like in practice. We're going to take a look at one of the most common operations there is, insertion. Now, in a standard linked list, adding a node to the very front is a special case, right? You have to update the main head pointer, check if the list was empty to begin with, all that jazz. But with Sentinels, things are way different. Now pay close attention to these steps. Yeah, we're inserting at the beginning, but this logic should look super familiar. Why? Because it's the exact same logic for inserting a node anywhere in the middle of a doubly linked list. We're just treating our head sentinel as the previous node. It's the same 4 pointer updates every single time. No special cases needed. And this is the magic moment. Did you catch what we didn't do? We didn't write a single if statement. We never had to ask, hey, is the head null? Because of our Sentinel guardians, we know for a fact the head sentinel and its next pointer are always there. The entire special case just, poof, vanished. How cool is that? This quote really just sums it all up perfectly. It doesn't matter if you're inserting or deleting or if you're at the start or at the end. With Sentinels, every single operation is treated like it's happening somewhere in the middle of the list. So what's the real-world impact of all this? Well, it's actually massive, and it goes straight to the quality and the reliability of the code that you write. I mean, this slide really says it all, doesn't it? On the left, that's the mental checklist for a standard list. It's this branching maze of questions you have to ask. And on the right, with Sentinels, you have one rule, one single unified procedure. The difference in complexity is just night and day. And the benefits are just so clear. When your code is simpler, it's easier to read, it's easier to understand, and most importantly, it's way easier to debug. You've basically designed an entire class of edge case bugs right out of existence before they can even happen. So why does this matter beyond just linked lists? Because what we're looking at here isn't just some clever little trick. It's actually a whole way of thinking. This is a classic example of a software design pattern. The core idea is using these placeholder or dummy elements to create boundaries that simplify your logic. By making sure your main algorithm never has to deal with a truly empty state, you make the algorithm itself radically simpler. And that brings us to a final thought. This pattern isn't just for linked lists. Think about it. Arrays, trees, any other data structure you work with.
Where could adding a dummy element at the boundaries get rid of a whole bunch of if-else checks and make your logic cleaner and more robust? It is a really powerful concept to add to your toolkit. Thanks for digging into this with me.